Voyager 1 is a masterpiece of 1970s engineering. For over 45 years, it has operated flawlessly, navigating the solar system and eventually crossing over into the interstellar void. But in late 2023, the clean stream of scientific data abruptly died. The spacecraft started broadcasting a repeating, incomprehensible pattern of binary noise. Diagnosing a problem in deep space is difficult, but the real bottleneck is a Unlayered itself. The computers running the ship were built in 1977. To put that into perspective, the key fob that unlocks your car holds more memory than Voyager's entire system. Compounding the vintage hardware is the sheer distance. At over 15 billion miles away, the speed of light becomes a serious physical barrier. By the time the antennas on Earth pick up an error signal, that error has already been occurring for almost a full day. This combination of a 24-hour transmission delay and ancient circuitry meant ground control was effectively helpless. Every diagnostic command they sent required a 2-day round trip, forcing engineers to wait and watch as our furthest set of eyes went completely blind. You cannot dispatch a repair crew to interstellar space. To figure out what broke, engineers had to meticulously comb through the probe's flight data system line by line from Earth. They traced the catastrophic failure to a single memory chip, which was likely knocked out by a high-energy cosmic ray. Because the physical hardware was permanently damaged, the team had to rewrite the operating software to bypass the corrupted section. They solved it by slicing the essential software into smaller fragments, surgically packing those pieces into the remaining healthy sectors of the memory drive. The patch worked. After months of transmitting noise, Voyager re-established a clean link and resumed sending coherent science data back to Earth. But a software patch cannot reverse physical decay. The spacecraft's internal components continue to deteriorate against the freezing, radioactive environment of deep space. That deterioration is most critical in the power supply. Voyager generates electricity using radioisotope thermoelectric generators, or RTGs. These generators rely on the natural physical decay of plutonium-238 to produce heat. As the plutonium slowly spends its energy, the total electrical power available to the spacecraft drops by a few watts every single year. Operating the ship now requires a ruthless electrical budget. To keep the primary transmitter and the central heaters warm enough to function, NASA has to periodically permanently disable the onboard science instruments. On April 17, 2026, engineers sent the command to shut down the low-energy charged particles experiment. After collecting data almost continuously for over 49 years, the instrument finally stopped rotating and went completely dark. It is a brutal calculation for survival. To ensure core communication systems keep running for another year, the team must systematically amputate the sensors that give the mission its purpose. With its code patched and its power consumption stripped to the bare minimum, the probe continues outward, functioning almost entirely on its own. This outward push brings us to November 13, 2026, when its trajectory crosses a distinct mathematical boundary. This visualization shows the scale. Voyager 1 is the first human-made object to reach a distance of exactly 1 light day from Earth. At this scale, a radio transmission takes an entire 24 hours to reach the antenna, and another 24 to return. Eventually, the plutonium will run out, and that communication link will drop for the last time. But the physical chassis of the probe, carrying the golden record encoded with Earth's sounds and images, will remain intact. Cut off from its creators, the machine transitions from an active scientific observer into an enduring artifact, drifting quietly through the dark.